As I said, in this lecture, we're going to see about relativistic quantum closed strings. So you have to understand the fundamental difference between open strings and closed strings. So maybe in your high school, you would have studied something called open interval and closed interval, right? So if you had a interval written down like this, it means the endpoints are not included in this interval, right? So this is a open interval, right? So this is a open interval. So it is same with, so this, it's the same condition with open and closed strings. So if I write it like this, then here it means that the interval is closed, right? So here the endpoints also are included in the interval. So that is what the open and closed strings here, the interval also means here. Okay, so here in open strings, the bound in the boundary condition, if you say, if I have a boundary condition which is, let's say, 0 and 2 pi, this is for a open string, right? And this is for a closed string. So here the endpoints are also included in the closed string. Okay, so you can immediately see what this will imply in what this will actually imply, because if the endpoints are also included, then it would work out like a periodicity condition, because uh, at 2 pi, at the interval 2 pi, 0 and 2 pi are not differentiated, right? Because 2 pi, it means you have done the, because so 0 and 2 pi are not differentiated because they are the same point, because we have the solutions for a string in terms of the sinusoidal function, and for a sinusoidal function, 0 and 2 pi are is essentially the same point, right? You do a complete rotation 360 degree and come back to the same point. So it's like the same point on the circle, right? So therefore, for a closed string, we have a periodicity condition to work with. Okay, and for an open string, generally the solution of any string problem reduces to waves. If we have solution in terms of waves, we have waves moving towards the left and waves moving towards the right. So the way the boundary conditions relate the waves moving to the left and right at the end points of the string, right? So the boundary conditions at the end points will relate the waves moving to the left and the right. However, for a closed string, we have a periodic boundary condition to work with. Okay, so that is expressed in the mathematical form this way. So here we have the solutions written in our general oscillator model expansion, and here you can see that there is a bar used to denote the coefficients, or which eventually will convert to operators. The bar refers to the ones corresponding to the left moving wave, and just the one without the bar the coefficients without the bar refers to the ones with the right moving wave. Okay, so the entire solution can be written out this way. The both are combined, left and right moving waves are combined, and if you want to quantize the theory, you just convert these coefficients to operators. So just like we did for open strings, we just do the entire same process. You just convert these coefficients to operators and you will quantize the